Welcome back to Share Science, the weekly science brief for July 20th, 2026. I'm Curie.
And I'm Derek.
Okay, so here's something wild. 252 million years ago, life on Earth nearly ended. 90% of marine species and 70% of land vertebrates were wiped out. Today, we're finally learning exactly why it happened.
That's such a staggering number. 90% of marine life gone? What could have possibly caused something on that scale?
It's called the Great Dying, and it makes the asteroid that killed the dinosaurs look like a minor event in comparison. This was the Permian-Triassic mass extinction, and for decades, scientists have debated the exact mechanism behind it. We've known that massive volcanic eruptions in Siberia released huge amounts of carbon dioxide, triggering global warming. But the question has always been, how did that warming translate into such widespread death?
And now, researchers think they've finally solved it?
Yes, a Stanford-led study has pieced it together. The key was the combination of rapid ocean warming and deoxygenation. As the oceans heated up, they lost their ability to hold dissolved oxygen. Marine animals that couldn't adapt to these low-oxygen, warm conditions essentially suffocated. It's like the oceans themselves became uninhabitable.
That's horrifying. And there's evidence in the fossil record that supports this?
Absolutely. The survivors of the Great Dying were species already adapted to low-oxygen environments, while those that couldn't cope were wiped out. It even explains why certain groups of animals, like brachiopods, were largely replaced by others, like clams and snails, after the extinction. The event reshaped life on Earth in ways that are still visible today.
And there's a modern parallel here, isn't there, with our warming oceans?
That's the sobering part. The researchers point out that the cool, oxygen-rich oceans that existed before the Great Dying are similar to the oceans we had before humans began warming the planet through fossil fuel emissions. It's a stark reminder of what can happen when climate systems are pushed to their limits.
It's a chilling thought. Let's shift gears to something a little more uplifting: Mars. NASA's Perseverance rover has just completed a marathon, and I have to say, there's something poetic about that.
I completely agree. The idea of a machine we built, driving 26.2 miles across the surface of another planet, it's incredible. And the Mars Reconnaissance Orbiter even captured a photograph of Perseverance from space, showing the rover as a tiny speck on the Martian surface, with its winding tracks trailing behind it.
How long did it take Perseverance to complete this marathon?
5 years and 4 months. Perseverance landed in Jezero Crater in February 2021, and it reached the marathon mark on its 1,891st Martian day, or SOL. To put it in perspective, the rover's top speed is about 1/10 of a mile per hour under ideal conditions. Every meter of driving is carefully planned to avoid hazards that could end the mission.
And this is actually the fastest a rover has ever reached that distance, right?
That's correct. The only other rover to drive a marathon on another world was NASA's Opportunity, which reached the distance back in 2015. But it took Opportunity 11 years and 2 months to get there. Perseverance did it in less than half that time. And it's still going strong. It's now less than 2 miles away from breaking Opportunity's total off-Earth distance record of just over 28 miles.
But of course, the distance isn't the point. It's what Perseverance has accomplished along the way.
Exactly. Along its journey, Perseverance has confirmed that Jezero Crater once held a lake, explored an ancient river delta, used ground-penetrating radar to peer beneath the surface, and collected samples that may one day be returned to Earth. It's also hunting for biosignatures, chemical traces that could hint at whether Mars ever hosted life.
It's a testament to human ingenuity, isn't it? Let's shift gears to a story that takes us to the depths of the ocean. Researchers have discovered a hidden food source in the deep sea, And it's changing how we think about one of the least understood habitats on the planet.
This is such a fascinating discovery. The deep ocean is a cold, dark, high-pressure environment where life depends on what's called marine snow, a constant drift of organic particles falling from the sunlit waters above. But this new research found that the extreme pressure of the deep sea actually squeezes nutrients out of these sinking particles, creating an unexpected food source for microbes.
So the pressure itself is essentially creating food.
That's right. As organic particles sink deeper into the ocean, the increasing pressure physically compresses them and releases dissolved nutrients into the surrounding water. It's like squeezing water from a sponge. This process makes those nutrients available to microbes in the deep water column, which changes how we understand the deep sea food web.
And this has implications for the carbon cycle, doesn't it?
It does. The ocean is one of Earth's great carbon sinks. When organic matter sinks into the deep sea and gets locked away, it removes carbon from the atmosphere. But if pressure is liberating nutrients and feeding microbes higher in the water column than we thought, it affects how much carbon actually gets stored in the deep ocean versus recycled back into the system.
It's amazing how something as simple as pressure can have such a profound impact. Speaking of profound impacts, let's talk about gold and why it never tarnishes. This is a question that's been hiding in plain sight for centuries.
Gold's resistance to tarnishing has always been one of its most remarkable properties. Unlike other metals which oxidize and form surface compounds, gold remains gleaming and untarnished. And now, researchers have finally explained why.
So what's the secret?
The researchers discovered that atoms on the surface of gold spontaneously rearrange themselves into specific patterns, a process called surface reconstruction. This arrangement physically blocks oxygen from getting close enough to react with the gold atoms. It's like gold has a built-in self-defense system.
And this isn't just a curiosity, it has practical implications, right?
Absolutely. Gold is used in electronics, medical devices, and aerospace because it doesn't corrode. Understanding the precise atomic mechanism that gives gold its stability could help engineers design better protective coatings for other materials, essentially borrowing gold's trick.
From gold to the human brain, our final story is about how a second pregnancy reshapes the brain differently than the first. This is such a fascinating area of research.
It really is. Pregnancy is one of the most dramatic transformations the adult human brain undergoes. We've known for years that pregnancy causes measurable changes in brain structure, particularly in regions involved in social cognition. But this new research shows that a second pregnancy brings its own distinct pattern of changes.
Why might a second pregnancy affect the brain differently?
The brain that enters a second pregnancy has already been remodeled once, so it's starting from a different baseline. The same hormonal signals may act on already altered circuitry and produce different effects. Plus, there's the accumulated experience of having already parented a child, which itself shapes the brain.
It's a reminder of how dynamic and adaptable the human brain is. What an incredible week in science.
From the great dying to the living, changing brain, it's been a journey. Thanks for joining us, and stay curious, everyone.